So, students, today's topic is field density test. So, how we perform this field density test, and what is the purpose of this test, and how do we perform this test? So, we gonna discuss these things in this video. So, let's start. You may see from its name, field density test. So, this test is performed in the field. We take a field density of the required area where we want to check the compaction. So the purpose of this test is to check how much compacted is sand in the field. So we have two densities. One is the field density, and the other is laboratory test density. So we have first of all we perform a test on the same soil taken from the field where we want to check how much is the density. So we take the soil to the laboratory and we have full furnished environment where we check the maximum dry density for the soil. So from that we have moisture content and the maximum dry density. That's another topic. So we take field density and the proctor, we take the ratio and we have our purpose, that's compaction of the soil. So to perform this test, first of all we have a calibrated sand, that's a unit mass of the soil. So and the other one is the apparatus for the field density, that consists of a cone and a jar which contains sand. Where we perform this test, we have to make a hole. So, and the material is extracted from this. So, mass of this extracted material, and we take the ratio of the mass from the field taken from this hole and the unit weight of the calibrated sand. So, this gives us the volume of the hole. After that, we take wet density, that is mass of the material from the hole, contains also moisture. So that's why we call it wet density. And this volume of the hole we divide by this mass of the whole material from the hole and the volume of the hole. So in the final we have a field density, that is the dry density, which is found out from the wet density multiplied by 100 our moisture content percent plus 100. So that's it. So we have the densities, and then we know we have a water density as well, and we take the ratio of the fuel density and the water density. So this gives us our required compaction.